important changes, consensus changes that are mostly related to compatibility with the Ethereum virtual machine. There are 6 improvements proposed, and I believe 3 or actually 4 of them are compatibility related, and then there are 2 remaining ones that are improvements to the two-way peg, basically the bridge between Bitcoin and Rootstock. So we will have the guys explaining each of those and opening up for comments. The teams, the core teams at IOV are actually already working on the code implementation of these for some time. They are that's quite advanced. I believe it's the last testing phase currently happening. And of course, after this meeting, the idea is to give the community some time, a couple of weeks at least, to receive comments to basically see if we are okay to move forward with releasing and activation. There are no specific dates for that yet, but our idea or general feeling about how things are progressing is that this, if there are no pushbacks or comments against moving forward from the community, we may see this happening, or we may see this being released probably next month in February. So things are quite advanced. Actually, there is a release candidate that it's already available, publicly available for anyone to review, that contains the code for each of these 6 improvements. That, as I said, they are still being tested. So the link is there. Probably someone can share that as well. But everything it's quite advanced. And we also will take the opportunity today to have Sergio commenting on one RSK IP. I don't recall the number, guys. Sorry, but it's the one about parallel transaction processing. 144. Sorry, it's quite old one. But also the teams have been working on this, but it's not ready yet to be included in Arrowhead. But the idea is that we can have Sergio talking about this as well. Maybe we can see that happening in a future network upgrade. So yeah, that's basically it. So maybe we can start with each of the RSK IPs, guys. Maybe we can move to next slide. Okay. So I guess it's you, Vlad. Maybe you can take it from here.
Hello, everyone. Yeah, let me talk about this one. It's about push 0 opcode, new opcode. The idea behind this RSK is to introduce a new instruction, push 0, which pushes the constant value 0 into the stack. Actually, other similar already existing instructions like push 0 or push 30 require extra input data, which specifies values that we want to push into the stack. This one, on the other hand, doesn't require any extra input, and as a result, it reduces final contract size. Advantages of adding it: obviously contract size smaller, scalability, and it improves compatibility with Solidity. Quite straightforward. Yeah, I guess this is it. Anything, guys, to add to this one?
Sounds good.
So what's next?
Can someone move to the next slide, please?
Oh, great.
I'll take this one as well. Okay, RSK IP 412 base fee opcode. In Ethereum, this opcode is already there and returns block base fee, obviously. In Rookstock, we don't have a concept of base fee, but in order to be compatible with the Ethereum ecosystem, we decided that it would be a good idea to introduce this instruction, but instead return block minimum gas price. Benefits of doing this, we get compatible with Ethereum and Solidity, so no more invalid opcode errors. Obviously, usability in Solidity just one line, block base fee. And it adds new capabilities to contracts. For instance, we can check network congestion, etc. This is quite similar opcode, which returns only one single value. And in case of rootstock, it's a minimum block gas price.
Actually, I would add here that the two concepts are quite similar from the point of view of contracts that want to detect if there has been a network congestion. It's almost the same, even if internally they work differently. I think that they were quite similar in terms of usage within the smart contract. So it's great that we already had this concept of minimum gas price from the creation of Rootstock.
Yeah, but I guess my benefit is we get compatible with EVM, so no errors inside contracts. Should we move to the next one?
Yep. Who has the... Okay, so this ERSK-IP is also quite old. It's ERSK-IP 203, and it's called the call gas get call stack depth precompiled contract. So the reason we created this ERSK-IP and we pushed for the activation of this is that we decided very early that we wouldn't adopt the EIP 150, which reduces the consumption of gas in 1/64 in each call inside the EVM. And the reasons we decided not to implement this, and we had very strong reasons, is related to the estimation of gas consumption of transactions. If we had added this EIP, then we would need to do a binary search as Ethereum does, and this just complicates and makes this process, which happens constantly at every transaction that is sent to the network and must be estimated, and it becomes very heavy in terms of processing. So we decided not to implement EIP 150, but since decided that, then we had this collateral problem, which is that the gas is not the only variable that affects how contracts are executed when you call a contract. Basically, if you are at a very big depth of the call stack, then you may be unable to fulfill the processing of the transaction, and you cannot rely only on the variable gas. So what do contracts do to prevent this? It generally, this only affects contracts that have to execute certain payload on behalf of a user. These are generally called relayers. For instance, the flyover protocol on Rootstock and the Reef Relay protocols on Rootstock, they all have this concept of relayers. You receive a payload that is not actually owned by the contract, and somebody sends this payload, and there is a contract that executes this payload on behalf of the user, right? But since the conditions which you will execute this payload can vary depending on the stack depth, then somehow you have to make sure that you always execute this payload in the same conditions. So what do normally contracts in Rootstock do? They check if the origin of the caller is actually the sender, which means that it's an external transaction. It's not an internal call, which means that we are at the highest level of the stack. We have all the stack. This is great, but it has a couple of drawbacks. One is that this concept of origin is discouraged by the community because there is a tendency to think that we are going to move into a account abstraction where this concept of origin will no longer have these possibilities. It will be phased out in certain moment. So it's being discouraged. And the other way you can try to test if you have been called from a contract or from an external transaction, the top level of the stack, is using Xcode size. But this is actually error prone because if you are being executed during the initialization of a contract, then actually the caller has 0 code size. So this is not good. So why do we want to use another method? Because one of the possibilities of these relayers is to batch transactions, and they do batch transactions to lower the cost. Like if RIF-Relay, which is a system for account abstraction, wants to execute 10 transactions together in one single external call, then it lowers the cost for each one of the clients, for each one of the users participating in this batch. But currently, we cannot do that from RIF-Relay because that would require being called from a contract, right? And we have disabled being called from a contract by checking the origin. So everything I've said is just to justify that if we had a way to detect what's the size of the stack, we can make sure that we are not being cheated, that the caller always has enough stack space. So we introduce this new opcode, which is very simple. Like the implementation is actually just a couple of lines of code. It will just return the stack depth where you are calling it. So just 1 at the beginning, then 2, and at the different frames. So basically now these relayers can check if there is enough stack space, and if there is not enough stack frame space, they will just abort and do not process the transactions because they would detect that they are being cheated in some way. So it's very simple, but it's very powerful what it enables in terms of lowering the cost of these account abstraction schemes that are very, very common now. Yep, that's all. Who's taking this?
Cool.
Yep,
Are you glad?
I'll take it. Yeah, this one, RSKP 400, called data gas cost reduction. Quite useful and being awaited, I guess. This RSKP proposes to implement EIP 2028 to reduce gas cost of transaction data. In Ethereum, it was already done some time ago. And in Rootstock, it's still high, and proposal is to reduce this gas cost from 68 gas units per byte to 16. Why we need it? Well, advantages are obviously it improves scalability in general, as more data could be included in a transaction. But most importantly, this is quite useful for layer 2 scaling solutions in particular, like different kinds of rollups, etc. And yeah, it aligns with Ethereum in general. I mean, gas costs. I guess this is it.
Okay.
My side.
Hello, everybody. My turn now. So RSKP 376 is a quite simple one. Since RSKP 201 was implemented, that it included the emergency multisig in the Pauper redeem script. In order to make use of the emergency multisig, the op CSV opcode was added as part of the reading script to set the amount of logs that need to be mined before the emergency multisig can spend the funds. So in order to make those payout transactions compatible with op CSV, version 2 was set to those transactions. Well, the proposal is to also put version 2 to migration transactions. This doesn't have an immediate effect on the transaction. They can still be spent, but the motivation is to keep it consistent between payouts and migration transaction, and well, at the same time we will be compatible for future upgrades in the POPEG.
Okay.
Well, any questions
yeah,
about this?
No, I understand, Marcos. It doesn't have any impact on users or on anything like that. It's only a matter of including this B2, but since it's consensus change, it needs to be included as part of a network upgrade, right?
Exactly, and yes, mainly to keep compatibility between migration and payout transactions and make sure that any future changes don't affect one or the other.
Yeah, maybe you want to briefly explain what a migration is.
Yeah, that's a good idea. Well, a migration it's a special type of transaction. It is created when there is a POPEG composition change. So sometimes new members are added to the POPEG or removed or changed. Maybe one comes in and one goes out. When this happens, all the funds contained in the retiring POPEG need to be moved into the new POPEG address. So this is what we call a migration transaction. It's a transaction that sends all the funds from the retiring POPEG address into the new address. But internally for the bridge, there shouldn't be any difference between what a payout transaction or a migration transaction. The bridge should only care about registering the UTXOs that will then be used to create payouts.
Great. Yeah, I just want to add there that these migration transactions are created automatically by the bridge in a consensus manner. Like there's no human intervention. Is the bridge they're responsible to move the funds to the new multisig?
Exactly. Thanks, Jorge. Okay, this RSKP 379. This also doesn't have a direct impact in users, but it adds, it basically focuses on scalability in the bridge and simplifying a lot of processes that occur when the bridge needs to register a transaction. We were just talking about payout and migration transactions that when those come to the bridge to be registered, what the bridge needs to do is register the UTXO that was sent to the POPEG address so that it can then be spent in future payout transactions whenever a user requests their funds. The other type of transaction that can be registered in the bridge is a peg-in. That's when a user wants to peg Bitcoin and transform them into RBTC. So that, well, in that case, the bridge also registers the UTXO that now will be available to use it in future payouts, but it also transfers RBTC into the user's Rootstock address. So the current way that the bridge tries to identify what type of transaction it received is by doing some complicated parsing of the reading script in the inputs of the transaction. And that process has become a little bit more complicated as new protocols were added to the bridge. For example, the flyover protocol. There was also a proposal to support ordinals. In the bridge, all those protocols involved adding new parts to the POPEG reading script. So then the bridge needs to handle each of those new protocols, each of those new changes to the reading script, and it starts becoming a bit complicated and risky. So the proposal is to have an index where the bridge can simply store the SIG hash of the first input of every transaction that was created by the bridge, every Bitcoin transaction that is a payout or a migration. So that way, whenever these transactions are registered in the bridge, can simply use the index to detect it, and the bridge can decide, okay, if this is the SIG hash of this transaction is stored in the index, then this is a transaction that I created, so I need to store those UTXOs. If it's not a transaction I created, but it's sending funds to me, then it's a begin. So that simplifies things quite a bit, and it also makes it more scalable for future protocols or improvements or whatever. I mean, it provides a very simple way for the bridge to detect the type of transaction it's dealing with.
Marcos, I have a question. I don't know if you can answer this on the fly, but maybe is by doing this, we will remove any type of identification of transactions by looking at the scripts. Like
Yes.
this removes the whole problem.
That's really
okay. So that's cool. There will be no other part where we will be executing. Okay, great.
Yeah. Exactly. It simplifies, solves possible risk on executing scripts from transactions received by the bridge. So the idea is to keep it as simple as possible and safe.
Okay, so this I will start with this because I was the writer of this RSKIP. Although so many people have worked on this that I'm this is a really team effort. But sadly, it's not going to be in this release. But I hope really that the next one we can have this. So this started like in 2016 with the first proposals to do parallel transaction processing. Some RSKIPs that were before RSKIP 144. Then we switched to the Unitry, and then we found a way to do parallel transaction processing, which based on the Unitry was much better and much simpler. And this allows to parallelize, as I said, the execution of transactions. This brings more scalability. We can have bigger blocks in terms of the total gas consumption or the total gas limit of the block. So it's really great for scalability, and it will lower the cost of transactions on the long run. The research team at IOB Labs have been doing a great work. I've seen the report. I hope this report is published to the community because it's really very interesting what they've done. They've tested this under very stressful scenarios, and they reached the conclusion that there's going to be a big scalability gain, speed up with implementing this RSKIP. But as far as I know, the core development team has taken this into their own responsibility to finalize the implementation, and they are still testing it. So that's why it didn't go into this release. Maybe Vlad, can you give us an update of how it is this testing processing going on?
Yeah, sure. One of the pending things is proper gas distribution across parallel lists, and this is quite complex stuff to tackle. We actually plan to have something ready by the end of this quarter. Yeah, we need to do a lot of tests, but it's quite promising.
Great. Fantastic. So we will bring this again in the next community core development calls, but you are very welcome to review it and give your opinion, because this is a very important change.
Yeah, there is an open pull request, so everyone can take it, look into that.
Yeah, there is some conversations around parallel in terms of how this will be rolled out. There is, of course, this is for future discussions and not part of Arrowhead, but there is a chance that this is probably rolled out to testnet first, and we see it in action in testnet for a few months before that's proposed to be included in mainnet. but that's still in the discussions. Now the team, as Vlad is saying, is mostly working on how to handle the block gas limits, and by having different threads of execution, that's according to how the block gas limit is distributed, does not affect bigger transactions to be included in a block. But it's, as Vlad was saying, I think it's quite advanced, and as you said, Serge, the results have been are very promising. But at the same time, it's a quite sensitive change. So again, we probably see that in action on testnet before we can consider that to be included in mainnet. I guess it will be part of future community calls as well, to probably dig deeper into it. But yeah, it's quite promising, and yeah, we are eager to see that activated soon. Yeah. Cool.
Okay.
Not sure if Marco is joining, but yeah, basically as a summary. Hey, Marco.
He joined. Hi.
Hi, John. Well, I rejoined. I was always here, but lurking, lurking in the dark, waiting.
Yeah, we know.
But yeah,
Yeah.
we'll now open this to the community. Please post your questions. You can do it either on Discord or on Twitter or on directly on YouTube. If you do it on YouTube, we may even be able to fetch it here to the presentation, so we will be featured here. So please do. Of course, it has questions that have to do with RSKIPs or with what we have been talking in this call. That's it. If you have,
yeah, just while we wait for questions, if there are any, Marcos, if you let me, just recapping. This is open for comments in the research, the Rootstock Research Forum. I believe that link has been shared a few minutes ago.
it has.
Cool. So maybe anyone want to comment afterwards. That will be open for comments for a couple of weeks. About release and activation, as I said at the beginning, still not defined, but yeah, the general feeling is that it will not take long until this is ready to be released. We're thinking probably of mid-February, with activation happening probably 1 month after that. I'm talking about mainnet. Probably generally speaking, the activation on testnet happens before that, but still TBD, especially to see if there is any comment about these RSKPs. But yeah, I guess it's not that controversial, mainly about compatibility, as we've seen. So yeah, but anyway, you never know. So we will have it open for a couple of weeks. Yes, sir.
One comment, just to give a. So the RSKPs, most of them are open for discussion for years. Like some of these RSKP have been discussed over for a lot of time. So you don't have to wait until we talk about them in the community call. You can just, as soon as they are published, you can go and look at them, the new ones, and if you are against them or for any reason you think they could be improved, then there is a lot of time for the community to participate in each one of them.
Yeah, that's a good point, and actually anyone can create RSKPs as well. I mean, it doesn't have to be the core dev team, of course. There is the guys here are the ones that are thinking all the time of what are the improvements that can be included. But yeah, that's a great point, Serge. Yeah. Marco, back to you.
We have a question.
Yes. Because I created the ordinal proposal, I can tell you that there was a lot of interest, hype about ordinals, and so I created the RSKP to show that you can do that. But actually, there's a lot of work that needs to be done. And we were very busy with the previous RSKP that were more discussed and had a lot more debate than this latest one. So I encourage anyone from the community to start coding it, and we probably can help, but it's a lot of coding. So if there's a really interest from the community, or an external team wants to participate and maybe ask for a grant to implement this, I don't know, then surely this could be implemented faster.
Okay, thank you very much. If just going here on Twitter to see if we have any further questions. Remember that if you leave them on YouTube, it's easier to pull them here. And let's see. Oh. Okay. No, we don't have any questions either on this.
There is one. Sorry,
Jose.
Marco. There is one from Jose. Do you want to mention that one?
A new one arrived. Sorry, mine took a little bit longer to update. There it is.
Marco, do you want to?
Yeah,
answer that?
I already added it. He asks, "Are you working on adding compatibility for Segwit pegouts?"
Yeah, I can take that. Yes, we are. We have a plan. It's in the roadmap. But there are a couple of changes that they are planned to be done first in order to make the Segwit compatibility change secure. So one of the changes we would like to do first is creating a new protocol that whenever there is a POPEL composition change, the new POPEL address is validated and validate that it can be that all the members can sign transactions and spend from it before the new POPEL gets activated. This is all to increase the security on the bridge and the security on users' funds. And that's a step prior we would like to take before adding Segwit compatibility. But yeah, it's on the roadmap. It's what's coming in the short term, I would say.
I really love that. Like that. I haven't seen that in any other system. Like you say that before the migration happens, there will be a tiny amount of Bitcoins that will be migrated. Then the new POPEC will sign that to make sure that it has fully control of that address, and then that would trigger the migration of the funds, and this all will be automatic, right? That's the idea.
Exactly. It's a completely automatic process to ensure that the new address that will be holding the funds is capable of spending them, and all the signers are valid and working. But it's a fully automatic process, as you said.
So that's what I call the signing depth philosophy. Like you add a new layer that controls that everything it's working. Even if you have tested it, you still add a new layer to make sure that if anything goes wrong, then you are still protected. So I think that would be very important in terms of adding more security to the bridge. Great idea.
Yeah, we are currently in the process of writing the RSKP. So as soon as it's done, or we have at least a first draft, we will share it with the community through the research forum other networks. Obviously, we invite anybody to chime in and share their ideas, concerns, proposals.
Yeah, and I understand, Marcos, just to add a couple of things. You have already been working on some POCs and technical validations about the feasibility of moving to a Segwit enabled POPEG. So, I mean, it's not only about writing an RSKP, you've been doing some more work. Looks like you are very humble to mention that. But yeah, and one interesting thing about it is that it would enable to have a significant higher number of signatories as part of the POPEG, right? That's one of the most interesting things to me, apart from reducing costs of payouts, and which is also very relevant. But I understand it would take the POPEG to handle more than 60 signatories. Is that correct?
Yes, that's true. From the proof of concept we have created using Segwit, we were able to create a reading script that supports up to 60 signatories. So yeah, that will definitely increase decentralization a lot. So really, there's things we have been working on already. So they're really on the roadmap. The plan is to tackle them this year.
Amazing. Okay, Marco, I'm not sure if there is any other questions.
Not arriving any other questions. We'll just wrap this up. But first, I would like to remember you all that are watching to join our Discord and ask all your questions in the Tech Talk channel. Please feel free to reach out to at IOVers to tag the IOVers, to tag devs, to tag anyone you wish. Just don't tag everyone at the same time. Well, you can't, but yeah. Join our Rootstock Research Forum at research.rsk.dev. And remember that you can propose your own RSK IPs and discuss the existing ones. I have posted the links for the public repository here on the comments section, and it will also be on the Tech Talk channel on Discord. So please go ahead, join us there. Thank you all. Thank you to all the speakers. Thank you to everyone attending. We will be returning with other core dev community calls, with other community calls here on our channels, and hope to see you all again. I don't know if you guys want to have some final words.
Not me. Thanks so much, Marco. Enjoy you guys.
Thanks, everyone.
Thank you all. Well, looking forward to have more community participation on Discord or on the research forum. We are always there.
Okay. Thank you very much.
Bye.